Hi, everyone. Thank you for joining us. We have Tommy Papp here today conducting a webinar on 5 ways to win full air business. If you have any questions during the webinar, please use the question feature and we'll go over all of your questions and comments during the wrap-up section at the end. So without further ado, I'll pass this over to Tommy.
Thanks, Courtney. Yeah, thanks for joining us, guys, for another session. Today, we're going to present on the 5 ways to win bull air business. What better way to start off your Monday morning than with me? Oh. So what's the plan? First, we're going to go over the basics of bull air assemblies, also known, as wire braid air assemblies. We're going to get into the ground joint coupling features and benefits, which is really going to tie in with the hoses and your 5 ways of winning. And at the end, we're going to recap it with your specific 5 ways to win, and we'll be good to go. So first, here's a quick win for you right off the bat. Dave, my boss, said, Tommy, how are you going to do 5 ways to win? That's just ludicrous. I said, Dave, watch me. Here's one quick one. So we got universal couplings. This 4-prong, they're pretending to be kind of a better version of a universal coupling. If you see them out there on a wire braid air hose, we're not talking 150 PSI. That's up to 400, 600, 1,000 PSI. If you see it out there, get rid of it. One win. Look at us. Look at us. Look at all these winners. We got a guy down there on the bottom right. He's got the hand on the arm handshake combo, looking like a winner. All right, so a little bit more specifics here. Wire braid air hose, aka bull air hose. What are we talking about? We got sizes 2-inch to 4-inch, wide range of temperatures. So these things can, do things in the negatives, but really what they, pride themselves on is the high heat. I see like up to 300 degrees, sometimes 250. I think some of the high temp air hoses, might even go higher than that. The applications we're going to talk about today are mainly construction and mining, but wire braid air hoses are used for a plethora of things. They're just a strong hose. So, tons of applications, but today we're focusing in on the construction and mining use for air. Pressure ratings, vary between 400 and 1,000 PSI. Again, we're kind of honing in on more of like the 500 to 600 PSI. And again, we're going to be really honing in on the ground joint couplings, but it can be male NPT ground joints. It can be long shank cryptology nipples. It can be flanges. But for the sake of today's webinar, I'm really going for the ground joint line. I highlight here at the bottom the working pressure. This is what like a standard spec sheet might look like for an air hose. You got your 500 PSI working pressure. And reason why I really key in on this, and we're going to talk about it in more depth later, but it can be confusing. The ley line can be very confusing on these things because if I'm an end user, I don't see a pressure rating on the end connection. I only see what's written on the hose. So these hoses say, max working pressure 500 PSI, max temperature 200 degrees. Well, they don't do both at the same time, and they may very well be operating doing the same at the same time, and that's extremely dangerous. So educating them to realize that is going to be a big part of how we get some wins out of this. All right. Here it is in the field. I know I've got people that have been in the industry for a long time here, but I also have some people that are newer and maybe some people who don't play in this market. So I just wanted to show some pictures of it in applications. You got the top left, that's just it stored up. You got a crimped version up there. At the bottom left, you got your boss clamp assembly, which is going to be part of our strategy to win. Bottom right, that's our nice hose wall down in Boyertown, Pennsylvania at Campbell. Obviously, you see a flange there on the right, but on the left is going to be the ground joint with the wing nut. And then the top right, those are the compressors that we're really talking about if we're dealing with high heat. And a lot of those even have coolers in them. So again, I'm going to dive into this later, but I'm a visual guy. I think it helps to see it now. If you go across those, they're going to say, oh, don't worry about heat. We have a cooler. Even when those things are working, the temperatures are still ranging around 180 to 200 degrees, which we'll see with some multipliers and some testing that we've done is significantly going to derate that assembly. All right, so like I said, everyone's thinking the hose. We need to focus on the complete system. If you joined me for Crimpnology 101, that picture in the top left is a little less shocking, but it's my way to ingrain in your head that this Crimpnology system is a marriage. It's a union between the hose, the coupling, and the fitting, or the attachment method. So we really need to dial in what the ends are, how they're attached, and what this complete assembly is rated to, not just the hose. You obviously can use our coupling selection guide to determine what pressure ratings we're dealing with, but you got to tie that in with the pressure rating of the hose. You might need to use some multipliers if you got some heat going on. So just think of it. You can't just think about the hose. You got to dial it in, think about the complete system, and not even just the end. You got to talk about how it's attached. And your customer is generally not thinking that too far deeply into it. They're thinking about what's on the lay line, what their application is, and they kind of want to commoditize that. So here we go. Ground joint coupling basics. You got a stem, you got a nut, and you got a spud. This still confuses some people, and I totally understand why. The nomenclature out there is a little bit messed up because people might say, hey, I need a female end. And in my head, I'm thinking of, you know, a ground joint with a wing nut. But in their head, they might be thinking of a female spud. So just dialing it in a little bit more, I'm just going to go through kind of the components of the ground joint real quick and hopefully clear this all up for everybody. So top left, you got your male stem. So just coming out of the hose, it's just going to look like a male NPT. That's easy. But then you got your female stem, which has the wing nut coming over it, and it's going to be mating into the spud. And then you got your female and male spud. That just depends on whether you have a male NPT hookup or if you have a female thread to get into. Your two different types of wing nuts. This is a really good differentiator, and you'll see later we'll recap it as one of the wins that we can have. It's just a low profile connection. We offer the standard wing nut because that's what people are used to seeing. But our metal to metal with a Viton O-ring style design that I'll show you on the next slide allows for a hand tight leak free assembly. And no better way to differentiate yourself and hammer that point home to say, hey, you don't need to hit this wing nut again than giving them the low profile nut that they can attach by hand, tighten it down, and never touch it again until they need to take it off. And then of course you got your complete set. So there you got your female stem with wing nut mating into the spud, and that's a female spud, and that would be mated onto the tool. So here's a cutout of it. So you got your spud here at the bottom. You got your metal to metal. If you notice, in the middle, you're going to have a polymer seat that's sitting in that spud. Those things can fall out, but mainly what happens is they're going to hit that wing nut down, just like you do for like a steam application, but it's for air. They're going to hit that wing nut down. It's going to take a set into that polymer seat, and it's just not going to be an efficient connection. The issue with that is that compressor is going to overwork. So we take that problem out of this entire situation by putting the Viton O-ring seal in our stem. So if you looked at our spud versus the competitor spud, our spud is metal. There's nothing in it. The competitor spud is going to have a polymer seat in it. The big key here for you is that they're interchangeable. So there on the right, you can see a cutout of how ours still mates in to the competitor spud, which is generally speaking going to be the one that you're running into out in the field, just because they have most of the market. So our stem, your hose end, is going to mate into that competitor spud, have no issues, and then like anything else, you kind of do a running change as that wears down. So here, just one more time, a little bit, blown up picture of it. You got the metal to metal mating area, you got a Viton O-ring secondary seal, and now it's a hand tight assembly. So on the left, that's a complete Campbell solution. On the right, that's a Campbell stem into a competitor spud, which is nice because that's what you're going to be dealing with in the field. But the key win here is going to be that hand tight assembly. One last time, why is that important? Interchangeable with what's in the field, better connection, which is increased efficiency. Not to mention, it's all the same price to you. What are you waiting for? All right, so now we're blown back out. You got stem, nut, spud. You're connecting to that compressor. You're connecting to a tool, what have you. Hopefully that clears things up a little bit for everyone. Got the dialog box on the right. If you guys have any questions up to this point or any questions moving forward, please type them in. I've got Rob answering questions, and I've also got him going to be reading some of them out to me at the end. But just don't forget to add any questions you've got into the dialog box. Time for a poll. I hope you are all paying attention. All right, let's launch it. A Campbell female stem ground joint coupling will mate to a Dixon spud. Yes or no? Ooh, people saying no. Come on. All right, give it a couple more seconds. We've got 840 people here today, so it's going to take a minute. 80% of you have voted. I'm just kidding, there's not 840. All right, we'll close it down. Show poll results. Sorry, getting used to this, guys. I think you can see it. All right. Great job. 96% of you said yes. Yes, we interchange with the spuds that are out there. We had to design something that's going to work with what's in the majority of the field. So you're going to not have to run into any compatibility issues on that side. Something to note, though, if you have a Campbell spud, which is only a metal seal, and you have the competitor's stem going into the Campbell spud, it'll connect, but there's no sealing point because our sealing point's in the stem. You get my drift there, that they don't have any way of connecting to ours and having a sealing point, since our Viton O-ring is in our stem and their sealing point is the polymer seat in their spud. Haha. Some more winners. We got the fist pound in the bottom left. Look at these two just winning. It's going to be us soon here. It's going to be us soon. The attachment method. All right. So first off, we might be up against some bolt clamps out there. If you can't get the person to change, work with them on it. It's fine. It's not like a bolt clamp is a bad connection. The problem is they don't retorque them. So if they're not going to change on the boss clamp because that's what they've been using forever, they like that it's field repairable, give them a U-bolt. It's got a 360-degree compression. It's got interlocking fingers that basically act almost like a ferrule onto the end of the coupling, and you got the bolts just on one side. So that's a win from me to you because your assembly team is going to like me more. It's not as hard to put together, plain and simple. The bolts are on one side. You don't have to flip the thing over, torque them down. You got them all on one side. Out in the field, it's lower profile. So if they're field repairing, they're going to enjoy that aspect. But if they're just using it, it's just a lower profile design. It's going to get snagged on less stuff. Kind of made a joke. I mean, the other style key points, I'd say they are on A, but that's your words, not mine. Here's a picture of a hose. Obviously, that's a steam hose there on the right, but it's a good representation of what happens. Just it's going to be on a larger scale level. So you see here, this bottom hose compression, that's a U-bolt compression. It's got that inner liner right here that wraps halfway around the hose. And then you got the yoke on the top that's going to complete that 360-degree compression. And then those interlocking fingers are going to retain it. At the top, that's from a old style clamshell clamp, which does not compress all the way around the fitting, that causes a leak path, more inefficiencies. So we're talking inefficiencies at the face of the coupling mating to the spud, and we're talking about inefficiencies at the retention to the hose and the stem. So that's two issues there that we've solved. The one warning I've got to say is that you must retighten clamps before each use. And the idea obviously behind that is you bring that up and they're pretty much never retorquing them. And that is really the downfall of a clamp style attachment. It's not to say that you don't still go for it and give them an upgrade when they are using them. It is just very important to note that they are supposed to be retorquing them. And that's why the backup testing is important. So this 1,000 PSI rated hose exploded at 5,200 PSI, which exceeds the 4x safety factor. That hose failed before the fitting ejected, in line with everything else that we do. These U-bolts perform fantastically well. They perform, if you see here at a 2-inch, they perform better than a long ferrule crimp connection, actually. Something about that liner, real quick, I'll show you. This liner grips into the hose a bit better, allows for higher pressures. So if they are retorquing them, if you find, the unicorn out there that's retorquing bolts in the field, this is actually a better product. It's going to perform to higher pressures and higher temperatures. But anyway, like anything else, this clamp is going to be to Campbell standard for blowing up the hose. It's a great product. Now onto the superior method of attachment with crimpnology. So you're going to measure the hose. You're going to use the chart. I can send you guys my lovely recording that I did last week if you didn't hear my crimpnology webinar. But if you stay within those parameters, you got the plus or minus 10 thousandths tolerance. We're standing behind this assembly as a 4-to-1 safety factor assembly. So just like that U-bolt, this crimp, more permanent attachment is going to blow up the hose. It's going to perform. The next thing that we're going to get into really is getting into the temperatures and how that affects all of this. But in an ambient setting, you can stand by these performance ratings there. All right. One more poll, everyone. One more poll. Let's see. Courtney, I might need your help. Here we go. Have you seen the aftermath of a wire braid air hose failure? There's no right or wrong answer here. Made it easy on you. All right, give it a couple more seconds. Don't worry, I'm getting to the 5 ways. Getting to the 5 ways. I've already covered a few of them. I just haven't explicitly said that they were wins yet. Okay, most of you have voted. I'm going to close it down here. Pretty tight. We got 53% saying yes, 48% saying no. That's good. That's kind of what I wanted. Some of you might be able to chime in here at the end to let us know how that goes. But misinformation is scary. Get the stamped info. This picture freaked me out. In 6th grade, I saw the ring, and I've never been the same. You shouldn't be the same after seeing a bull air hose failure either. So here we go. This is kind of like the map behind it, right? So you got the dynamic force chart. Like I said before, and I guess you can tell with my weird pictures, I'm a visual learner. This type of stuff, yeah, it means something to me. But I think the slides coming up next are really what's impactful. But if you look at this thing, you got 500 PSI, 2-inch hose. It's over 1,500 pounds of force. 3-inch hose, talking over 3,500 pounds of force. So what does that mean? It means this. So here's a failure that we came across. This is a 3-inch bull air hose. Tore it to shreds. Now that's a flange connection, obviously, but same retention within the hose. Why it happened, I mean, on the left here, it was a way harsher angle of a kink, so everything was just beating into the side of that hose. And when you're operating at, like we just saw, 500 PSI, that really packs a punch. So this hose on the right that blew off caused this damage. So luckily nobody was there, standing there, but that would have done some serious damage. It may have even killed the person. It tore this metal piece of equipment to shreds. And this is something that you can't take lightly. And this is why we need to talk about the complete system. They were probably misoperating, not to mention that angle they were taking was pretty ridiculous. But I'll show you a picture in a second where they weren't doing anything wrong. They just didn't understand that the ley line sort of lies to them. They're working at higher temperatures than they had expected, and that's going to derate the working pressure that they're allowed to use it at. And then what happens is failures. So here's one that was in my territory, and we got them set up with the next fitting that I'm going to talk about, the Heatwave coupling. But you can see here, this hose is completely blown to shreds, but the fitting is intact. I mean, at another situation, the fitting could have blown off and the hose could have been fine. This situation, the hose blew off, the fitting was fine. It was a fine crimp. We did analytics on it. The problem was it was higher temperature than they had anticipated. The compressor had a cooler. They thought that they were fine. It was still actually operating at, like, I think 210 degrees, and they were working it at max working pressure. All this negative, you're not feeling like these people yet, but don't worry, we're almost there. So here we go. Here's the math behind all that, the heat talk I'm talking about here. So let's quick bust out a calculator. Hopefully you don't need one for this math, but you got 0.42 at 200 degrees Fahrenheit, which is about what I was just saying that one hose failure occurred at. You know, you got a 2-inch hose. It was crimped, 1,000 PSI. That should really only be working to 420 PSI. But the ley line says 200 degrees, 600 PSI. So what are they going to do? They're going to work it at 600 PSI, and they thought that they were below the 200 degree threshold. So just beating a dead horse here, but misinformation is terrifying. The high heat is going to cause failures, but really what's happening is just they don't understand what they're working with, because a ground joint doesn't tell them what they're capable of doing, and the hose obviously isn't able to write out and say, hey, only do one at a time. So it's kind of a tricky situation, and that's where you step in, either as a sales rep, a customer service rep, you know, what have you, when you're selling this stuff, to educate these customers on the dangers of it. And the great thing was that there's a solution to that. Here's one of your wins. So we got the Heatwave coupling. Basically, if you're familiar with the crimped steam, you got a staked ferrule with internal serrations on the ID of the ferrule. Now this, instead of the harsh serrations, is a wave, hence the name Heatwave. We took it from the liner of the U-bolt coupling. So the liner that sits beneath the yoke of the U-bolt has some waves for those U-bolts to sit in. We realized that since people weren't retorquing, we needed to have a permanent attachment for it. So you have the Heatwave coupling that has no bolts, so you don't have to worry about retorquing, and you have a permanent attachment. So Heatwave, you think high temp air hose, high temp fitting, it will hold the ley line at the max working pressure and the max temperature. It's really the complete solution for this. Now, we have tested it on a variety of hoses. This is just a snapshot. And if you want hose information, I'm more than happy to give it to you afterwards. You know, I just didn't want to promote or slight hoses that didn't do well. But the key takeaway for me out of this is, for instance here, you got this 2-inch hose, working pressure 600 PSI, 250 degrees, it says what it goes up to, right? So it holds the ley line to 600 PSI up to 225 degrees with a Heatwave coupling. So that's the complete solution, and it only holds to 600 PSI at 225 degrees. In my opinion, that's very good, because it's probably what they're going to be working it at. It tails off at 240. It says it goes up to 250. So even with the Heatwave, it doesn't hold what it says it's going to do. But the real key here to note is that if it doesn't have the Heatwave, this thing derates almost immediately like it would on a standard wire braid air hose. So it's just important to note that this heat is extremely important. It really changes how these things perform, and we have the information to back it up. And if you have any applications where you think there might be some temperature, it is definitely worth the conversation to at least bring this thing up to them. So to reiterate, you know, remember the system. They're thinking just the hose, and really what the new wave of thought has been is, hey, get me a high temp air hose. You know, they may have seen blow-offs, they may have heard of them, they're going with the high temp air hoses. make them know that they have to still have a high temp fitting on the end of that high temp air hose, because putting a standard connection on a high temp air hose is going to derate it all the same. So they're just wasting their money. So don't be fooled by the ley line. The standard connection cannot perform both the high temp and the high pressure at the same time, but the Heatwave can, depending on the hose. And we've tested them out. So if you have an application, say, Tom, hey, I'm going to use this high temp air hose. How did that do on the Heatwave? And I can give you the full report. So Nick Foles, big champ. You can be like him after these 5 bullet points we run through. We're almost done. So the first one, the quick one that I gave you, the 4-prong universal or a standard universal cannot be used for this application. Boom, get it out of there. Move to a ground joint, whether it's U-bolt or crimp, just get it out of there. The next win, hand-tight ground joint design. You got the low profile nut, or you can still stick with the wing nut. It's going to be the same design, but I really like that low profile nut. It's going to differentiate you out there. It's going to really show that you don't just say it's hand tight. They can try it out. They can use it. They can, figure it out for themselves. The low profile nut's nice. And the reason for that is we don't have the polymer seat in the spud. We've got the metal to metal connection. We've got the Viton O-ring in the stem that allows you to just hand tighten that down. Third one, you've got the U-bolt low profile design. Better for assembly, ease of use. The bolts are on one side. And then in the field, it's less bulky. It's going to be a superior connection. Again, to them, pretty much the same price as what they're already getting. So why not upgrade? I'll give you some free U-bolt clamps to get out there if you have some opportunities to change that business over. Long ferrule crimpnology connection. Obviously, everything that we pride ourselves on. You got the proven performance. We got benchmark testing available. Like I said, all hoses are not the same. You can come to me for that information afterwards. And then you got the ultimate Heatwave coupling, which is going to be for the high temp applications. It's holding the ley lines on the high temp air hoses. You got to keep them from thinking just hose. You got to think the whole assembly. So don't let them spend all their money on a high temp air hose without a complete solution, because it's just going to get derated down if you use a standard ground joint. One more time in pictures. You got one, get rid of these guys. You got the hand tight leak free, hand tight leak free, metal to metal seal in the ground joint, low profile nut, interlocking U-bolt clamp, bolts on one side, crimpnology, proven performance, Heatwave, high temp, proven performance. And I think that's it. So yeah, if you offer the best solution, you got if clamp, do the U-bolt, if crimped, crimpnology, if high temp, Heatwave. I hope I've burned this into your heads. Winner, winner, chicken dinner, guys. Winner, winner, chicken dinner. Thanks for listening. Rob probably has some questions to read off to me. But yeah, thanks again for joining me.
Great, Tom. We do have a couple of questions here. First one would be, can both nuts be hand tightened?
Yes, they can. So the wing nut, basically, the design. So the design of the stem with the Viton O-ring seal is really allowing that hand tightening aspect. So why we keep the wing nut is just like anything else. People are used to that wing nut. You got to supply what they're used to. They can hand tighten that thing down. I just feel that the low profile nut hammers that idea home a little bit more and makes them realize that it can in fact just be hand tightened.
Okay, next one is your U-bolt clamp. Can you put that on a non-Campbell ground joint?
You cannot. So the interlocking fingers are going to work with our ground joint design. I would imagine you can still, it's a clamp, so you can still clamp it on there. But one, we're not going to stand behind that performance. And two, I believe the design makes that a problem. But Rob, is that correct, do you think?
Yeah, I think you can actually get it on some of the other competitive ground joints that are out there. But you're right, Tom, it's that system. And if you're looking for a pressure rating, then you really need a Campbell stem with the U-bolt clamp in order to feel comfortable with that pressure rating. Anytime that you mix and match any supplier's parts, you're really just getting a hodgepodge, not a system.
But it will still kind of interlock on there if it is.
Yeah, I think a variety of the suppliers out there with their products. Again, we don't know every competitive design and whether it'll fit on there, but some of the names that it will.
All right, nice.
Another question was when you ask customers if they retorque the bolts, what are the answers you usually get back?
Yeah, they never do it. They pretty much will just laugh at you. Been laughed at plenty, so that's okay. Yeah, I mean, nobody does it. We do have torque specs available, so I don't want to just throw in the towel and say, hey, let them just keep never retorquing them. You can give them, the specs, but yeah, I mean, that's why, I kind of call the U-bolt clamp like the gateway to the crimping, because they might be using a boss clamp. They're used to the boss clamp. You encourage them to move forward, but they want the field repair. So you give them the better clamp. They're okay with that. And now that you've got them already kind of changing the way they think, okay, hey, let's try and introduce a permanent attachment crimp. And once you have that trust, you can just get them some assemblies crimped and they'll never look back.
Okay. Another question we have is what industries should we be focusing in on for these products?
Yeah, generally construction, but anything with large air compressors. So even if you want to go straight to the compressor company, I mean, Ingersoll Rand and Kaiser compressors, they're obviously all using these connections. Now, when you get to the smaller compressors, you're going to have that universal coupling because you're going to have like a jackhammer hose, 150 PSI. We're really talking when you get to the 2 and 3 inch air assemblies. So my experience has generally been rental, construction, more success with construction because, rental can be, generally when I've gone to them, they have the smaller compressors, but yeah, and it's used in mining. But I would generally say construction.
Okay. Jumping back to the U-bolts again, how many times can the bolts be retorqued?
How many times?
Well, I think the question is probably relating a little bit to the competitive one. The competitor says you should torque bolts until they bend, and that's to keep the bolt from backing out. Unfortunately, then you can only torque it that one time. So really, our bolts, depending on if the bolts are being over torqued in the field or not, you can cross thread them, and eventually they just won't allow that anymore. So the answer to that question is really a case by case basis and how they're used in the field. But the reality is that if torqued correctly, they should be able to do it many times.
Cool. And yeah, anytime you buy a U-bolt, it would come with the specs with it. So.
Right.
Yeah.
Will you do lunch and learns and training at job sites with distributors?
Yes. Yeah. Those are the best ones to do. So yes, if you want to, I'll be following up with everybody on this. But yeah, I've done plenty of those with my customers, and you kind of change your tune a little bit. I'm kind of just beating all this into you guys and saying, they're doing everything wrong. So I'll lighten that up a little bit, but yeah, I'm more than happy to do that. And if I'm not, in your territory, obviously we have sales reps covering the country, so we can easily set that up. So I'll be sending the follow up with the presentation, everything, but they'll have my contact info. Just let me know what you want.
I have to agree with you, Tom, that the showing the synergy between your supplier and the distributor out in the field with the end user is really a powerful message. And yes, you can't necessarily go out there and tell every end user they're doing everything wrong and expect them to believe everything you're saying. So that's why the test data and really knowing what some of the issues are that are occurring all the time in the field from one area of the country to another is a big deal for you. So, you don't need to know everything as a distributor because you're selling thousands and thousands of products. You just need to know where to find the answers and the support to win new business.
But yeah, Rob, if they're not using Campbell, I mean, I don't know what they're doing anyway.
Well, that's why we have people listening in today.
It's true. It's true. All right, is that it?
Yeah, I don't see anything else. So we certainly appreciate everybody's time.
Yeah, thanks everyone for joining me. Have a good week.